So, like I said, on Friday we introduced this. I want to kind of go through this in nice slow motion as we have multiplying binomials. So we had 3x minus 1 and 2x plus 5 we wanted to multiply. So what we did our 3x and our minus 1 on these two boxes, and our 2x and our plus 5 down here. And then we just multiplied each row by column to find out what that product was. So 2x times 3x is 6x squared. 2x across times negative 1 down is negative 2x. 3x times 5 is a plus 15x. And the negative 1 times positive 5 is a negative 5. Then, noting that these two are like terms, we put things together as a polynomial. So we got 6x squared plus 15x minus 2x led me up plus 13x, and then minus 5. So noticing when we put it together again, the 6x squared was what was in this box right here. Okay. The negative 5 was in this box down here. And the plus 13 was split up between those two boxes. And split up in just the right way to make the polynomial come together. What we're going to be doing today is we're going to be doing this process in reverse. Okay, so instead of starting with the factors and then getting our numbers in the boxes and putting them together, we're going to start by getting the numbers in the boxes and working backwards to find the factors. That's the way the box method of factoring is going to work for us. But before we get into that, I want to take a minute and just review basic factoring. So let's take a minute and just review what we did with some basic factoring work on Friday. So I wanted to factor and solve this equation. 8x squared minus, or I said x squared minus 8x minus 20 equals 0. So I take this particular polynomial, and we talked about a little bit about magic numbers. Now, our magic numbers help us find our factors. So my product here had to be negative 20. My sum was negative 8. Okay, so I need to find two numbers that multiply to give me negative 20 and add to give me negative 8. And of course, we're going to look at clues from the signs of the numbers to tell me about the factors that are going to do this. Because a product of negative 20 tells me that I have one negative number and one positive number. Because I can't get a negative product without multiplying a positive times a negative. The sum being negative also tells me that the bigger of those two numbers has to be the negative number. By bigger, I mean more absolute value, further away from 0. Now, in reality, what's going on here is a little teeny bit more complicated, but we don't worry about it because it's really what we're doing is there's a 1 in front of this x squared, right? And really to come up with this product number, we're actually multiplying the 1 times negative 20. It's just we don't worry about that because it's just a 1. Okay, having that 1 in front of the x squared really makes that a much easier. This is the easy situation. All right, so let's just figure out what my magic numbers are. Some of us are really good at coming up with this. Some of us are not. So for those who are not, I'd like to be really methodical about it. Negative 20 would be 1 times negative 20, but that doesn't give me a negative 19. So 2 times negative 10, aha, that gives me my negative 8. Right? And then, again, because this is the easy factoring situation, since this is my easy situation, my magic numbers are my factors. So just x plus 2, x minus 10 equals 0. And then whenever we're solving these factoring equations, We then set our individual factors equal to 0. So x plus 2 equals 0, or x minus 10 equals 0, which are simple one-step equations. X equals -2, x equals +10, okay? And those are my solutions. And as I'm sure we've all noticed, in this simple situation, my solutions are the opposites, the additive inverses of my magic numbers. Again, this is the easy situation. This is the piece of cake factoring. This is the stuff we like to see. So my solutions are actually the opposites of my factors. But again, my factors and my solutions are two different things. They are related, but they are not the same. So let's do one more example, and then we're going to turn you loose for a little while on just practicing this technique. Here my product has to be 56, and my sum has to be 15. Well, what numbers multiply to give me 56? Well, 1 times 56. 56 is one I use a lot. So 2 times 28. 3 does not go into 56. 4 goes in. 4 times 14, that's still not a 15. 5 doesn't go in. 6 does not go into 56. 7 times 8. Aha, there's my 15. So we got to be a little bit, 56 not being our most common number to factor. We want to be a little methodical about that. Some of you picked up on the 7 times 8 immediately. That's great. Not everyone's going to do that. Some of us need a little more. Let's get a technique down there so I can always find my answer instead of just guessing. Okay? So the magic numbers are 7 and 8. So the factors are x plus 7, x plus 8. So my solutions are x equals -7, x equals -8, the opposite of my magic numbers. And those are the numbers that when I plug into that will give me a 0 if I substitute those back in. So problems 1 through 6 are what we're going to start with. Let's take a look at those, work on problems 1 through 6. We'll just take about 5 minutes. Let's move on. Now, this is really where we need to be talking about today. And this is what happens when I do get a number in front of the x squared term. Okay? What happens when I do get a number in front of the x squared term? And when I have a number in front of the x squared term, things do get a little more complicated. We're still going to be looking for magic numbers. That's still going to be necessary. But we're going to use our box method to make the factoring a little bit easier, because our magic, unlike what we saw when there's just a 1 in front, when the a is a 1, and so it's just x squared plus whatever, and our magic numbers are our factors. When there's a number in front of the x squared other than a 1, if there's a 5 there, a 3, or a -7, or whatever is there in front of the x squared, then our magic numbers are not going to be our factors. They're going to help us find our factors, but they're not going to be our factors directly. And we saw that a little bit in our first example here. Okay? In this case, 6x squared minus 5. Let's just take a look at this. Notice if I take this 6 times -5, the a times c. 6 times -5, that gave me a product of -30. Right? And two numbers that multiply to give me -30 but have to give me +13. So negative product means they have to be different signs. Positive sum means a larger in absolute value is going to be positive. So that'd be -1 times 30. That's not going to give me a 13. -2 times 15 is going to be a 30. Or it's going to be a 13. So my magic numbers are -2 and 15. And what numbers, when we multiplied, wound up in these two boxes? What are the values we wound up with here? Negative 2x and 15x. See, this is where my magic numbers are going to help me in my factoring process, and where our box is going to become useful. Is their magic numbers are going to tell us which numbers go in the diagonal in our box. And then we're going to work our box backwards to find our factors. And I'll show you exactly how that's going to work. It's actually pretty nifty. Okay, so this AC method, we look at A and C, including the operand in front of C. If it's a plus, it's positive C. If it's a minus, it's a negative C. Okay, we multiply that A times C to get our product. Our sum is still B, and we look for those magic numbers, and our magic numbers are going to help us know how to fill out our box. And once our box is filled out, then it's a pretty quick little mini factoring problem to get our factors. Once we have our factors, finding our solutions are very quick. So, 10x squared plus 3x minus 4 is our first example. Okay? Actually, I'm wondering if I got a slide out of order. Yes. All right. Well, let's go ahead and do this. I do think I have a slide out of order, but that's okay. Let me show you how this is done, and then we'll break it down for a little more general terms. I'll do a specific problem. First, I'm going to find my magic numbers. So I have 10 and negative 4 are my A and C. So my AC is 10 times negative 4, which is negative 40. So negative 40 is my number. My sum has to be 3. Positive 3. So again, negative product means I'm going to have one number of each sign, one positive, one negative. Positive sum means the bigger number in absolute value has to be the positive one. So factors of negative 40 would be negative 1 times 40. That's not going to give me a positive 3. Negative 2 times 20 gives me an 18, not a 3. Negative 3 doesn't go in, so negative 4 times 10 does not give me a 3. Negative 5 times 8, aha, there's my 3. Right? So the negative 5 and 8, my magic numbers are going to go right here. But we know each of these boxes gets an x when we multiply, right? That this is my diagonal that's going to give me a 3x, because this plus this has to add up to that. So I have to have an x in each of those boxes too, not just the magic numbers. What's going to go in this first box? Well, same thing always goes when we multiply it. This, right? The 10x squared. And in my last box is going to go my negative 4. So now I've got my polynomial all set up in the box. Now I just have to figure out what's going to go on the sides of that box. What's going to go in the margins on the outside. So I'm going to look at any row, and I usually just look at the first row. Okay. Now, again, when we're setting these up and we're multiplying, we know that there's always an x here and an x here to get the x squared, right? But what's the greatest common factor between 10x squared and negative 5x? No, 2 doesn't go into, 2 goes into 10, but not to 5. 5 goes into both of them, doesn't it? So that means I'm going to get a 5x as my greatest common factor. Now, 5x times what to get the 10x squared? 2x. 5x and 2x gives me 10x squared, doesn't it? And 5x times what to give me negative 5x? Negative 1, right? Because 5x times negative 1 is negative 5x. Now if I actually put positive 1 here, I'm going to have an error, because positive 1 times 5x is not negative 5x. It has to be a negative 5x, because magic number there was negative 5. Okay? Now, 2x times what? Well, we could actually do it this way. Negative 4 divided by negative 1 is what? positive 4. And now check. Positive 4 times positive 2x, positive 8x. All of my boxes make sense, don't they? Okay? Whenever I multiply the row times the column there, all my box entries now make sense. I've decoded my box. And I've got my factors. My factors are my margin. 2x minus 1 times 5x minus 4. Those are my factors. And I factored that polynomial. Okay? I factored that polynomial. So in general, ax squared plus bx plus c. So it should be a big C, but that's okay. The way we plug the numbers into the box, the ax squared term always goes here. The c term always goes down here. And then my two magic numbers with an x go in the diagonal boxes this way. It doesn't matter which magic number goes in which box. All right, back here, I put the negative 5x and the 8x here. I could put the 8x here and the 5x, negative 5x over here, and I'd have wound up with the same factors when all was said and done. It would have looked a little different in process, but I wound up with the same answers. So it doesn't matter in which magic, these two are interchangeable. And when we're factoring, I know that this term always has an x and this term always has an x. Right? And then I just have to figure out what's the greatest common factor between these two, pull that out, figure out what, check it, see if it works. Pull that out, check it to make sure it works. Then this divided by, or this divided by that is going to be this number over here. Or you can figure out this times what number has to go there to make that work. You just work it backwards. Okay, this number times what has to be that number. And the box just fills itself out. The margins just work themselves out very quickly, and you have your factors. So let's look at this in action again. Do another example. Whoops. I want to move my whole box. Not just that. So I'll do this. Move my whole box. All right. First off, what's going to go in this upper left box right here? 3x squared is going to go in there. What's going to go in my lower right box over here?
12.
Negative 12. Okay. That's great. I now need to figure my magic numbers. Now, 3 times negative 12, that's my a and my c, isn't it? For my AC method. So in case there's any confusion, those two numbers, that is my a and my c. 3 times negative 12 is negative 36. That's the number I'm looking for. I want my sum to be positive 16. So negative 36, negative product, positive sum. So 1 times, negative 1 times 36. Bigger number has to be the positive one. That's not going to give me a 16. Negative 2 times 18. Ding! There's my 16, isn't it? So that means negative 2 and 18. It's going to be negative 2x and 18x. And again, both these boxes get x's because it has to add up to 16x. Okay, not just 16, but 16x. Now we just have to pull this apart. Okay? We know there's an x here. What is the greatest common factor between these two terms besides the x? 3 and negative 2. What's the greatest common factor? 1. Yeah. Or just plain x. So 1x times what is 3x squared? We're going to have the 3x up there. 1x times what is negative 2x? Negative 2. What times negative 2 is negative 12? And check it. 3x times 6 is 18x. I have my factors. I have my factors. Now, we're also going to solve these. So once I've found my factors, now I have one small task left, and that is to find the values of x that will make that actually 0. And what I'm going to do that is set each individual factor equal to 0. So 3x minus 2 is one of my factors, going to make that equal to 0. Or 1x plus 6 equals 0. And now these are just very quick little algebra problems. Add 2 to each side. 3x equals 2, divide by 3. X equals 2/3. Don't worry about decimalizing it, just leave it as 2/3, it's fine. If you get a fraction like 5/3, that's okay too, you don't have to turn it, just leave it be. And here, minus 6 minus 6, x equals negative 6. So my solutions are 2/3 or negative 6 when we're all said and done. So not only do I find the factors, once I find the factors, I find my solutions. And this time again, because there's a number in front of the x squared, it's the opposite of my factors are not my solutions. So definitely more complicated than if I just have a 1 in front. Okay? Let's do another one. Okay? Again, the 8x squared started right here. The negative 15 on the lower right. Okay, I know when I factor that I'm going to have an x here and an x here. In fact, I also know I'm going to have an x here and an x here, don't I? So I can put those x's in right away. My product has to be 8 times negative 15, which is negative 120. Oof, my sum is negative 14. Now, I don't know about you, but negative 120 isn't one of those things that have all my factors that just come right out of the top of my head. So I'm going to be methodical about this. So 1 times negative 120, no. 2 times negative 60, that doesn't give me negative 14. 3 times negative 40, that doesn't give me negative 14. 4 times negative 13, that's a negative 26, getting closer. 5 times negative 24, that's a negative 19, we're getting closer. 6 times negative 20, oh, there's my negative 14. Like I said, some of you are going to get to that 6 times negative 20 way faster. And that's great. I'm happy for you. Not everyone's going to. You don't have to go through every combination, but if you get stuck, this is a great way of doing this. If you can't think of it off the top of your head, just being really methodical about this is great. And if I had to, 7 would go in, 8 would go into negative to 120, and 8 times 15. Okay, we could keep going if we had to. 10 times 12, I think, is the last one. Well, we found our magic numbers. Our magic numbers are 6 and negative 20. There's nothing magical about which one goes where. It doesn't matter. But now I look at this first row. What's the common factor between 8x squared and 6x? We know it's an x and a 2. What's 8x squared divided by 2x? What do I have to put up here to get the 8x squared back? 4. So 4x and 2x is 8x. What do I have to put up here to get the 6x back? It's going to be a 3. Because 3 times 2x is 6x. 3 times what is negative 15? Negative 5. Error check. Negative 5 times 4x, is that negative 20x? Sure is. So not only is this like not that hard, it's built-in error checking all the way. If we check our box, if we go back and redo our multiplication, it's really fast and easy to check to see if we've done it right. Okay, so my factors are 4x plus 3 and 2x minus 5. And if we set that equal to 0 and we need to solve it, we just take each individual factor and set it equal to 0. Now these are going to give me fractions. Okay? Add 5 to both sides. 2x equals 5. X equals 5 halves. So my solutions are actually negative 3/4 and 5 halves. Those are not numbers you would just guess randomly. Which is why this method becomes very powerful for us to find more difficult solutions to more difficult problems. So our box really becomes useful to us now. Let's do one more and then I'm going to turn you loose. Oh, I guess I don't have one more to do. So let's start number 7. How about that? From your assignment sheet. Let's work together and let's get number 7 started for us. Not going to go all the way on it, but let's get it started. It's not a beautiful box. So, what's going to go in this upper left-hand box? 4p squared. Okay, so remember my polynomial here is 4p squared plus 17p plus 15 equals 0. What's going to go down here in the bottom? Right. 15. 4 times 15 is 60. That's my combination. It's positive, and my sum is positive, so all my numbers will be positive. So numbers multiply to give me 60, add to give me 17. Well, it's 1 and 60. No, it's not a 17. 2 and 30, that's a 32. 3 and 20. Now, some of us would be tempted there because negative 3 and 20 would give me a 17, but negative 3 and 20 don't give me a positive 60. So we'll be careful. We aren't subtracting here, we're adding. So 4 and 15, that gives me a 19. 5 and 12, there's my 17. This is going to be a 5p and a 12p. Now, when I'm doing my factor, we know there's going to be a p here. We know there's going to be a p here. What's the common factor between 4 and 5? Just 1. Okay? So what do I have to multiply 1 pi p by to get to 4p squared? 4p. What do I have to multiply 1 pi p to get to 5p? 5. Positive 5. Okay. 5 times what is 15? Check it. 4p times 3 is 12p. I have my factors. Now I need to find my solutions. There's number 7 all set up for you. And you can work through the remaining, finish number 7 and work through the remaining 5 problems in the time we have left. Pardon? When you're finished? What do you do when you're finished?